Alright class, today we are going to talk about growth and decay part 2, which is formulas. Basically what compounding and interest means is that you get interest based on your initial deposit into savings, and then after 3 months they'll pay you interest on that. Or I shouldn't say after 3 months, it depends on what it is. It could be N, it determines which time frame it is, but let's say it's quarterly, which means it happens 4 times a year. After 3 months, it gives you the interest, and then you earn interest on that interest. That's why it's called compound interest. So now your new balance will keep going, and the next 3 months you will earn interest based on your initial amount plus the extra interest you'd already earned. Okay? So everything else is pretty basic. P is the amount you put in, A is the amount you have after a certain amount of time in years, T is in years, N is the number of compounds per year, and R is the rate. Now, compounding continuously is something that happens mostly, I don't know if banking does it as much, but you can do it with banking. It means it just is continuously being compounded. There's no time frame. You see that more in like bacterial growth, because bacteria is always reproducing and growing. So, but this is the formula for that, so it's going to be using the exponential function e. It's the initial value times e to the r times t. There is no n value, it is built into the e. Okay, so let's see how this works. We're going to deposit $9,000 in an account that pays 1.46 annual interest, so r is equal to 0.0146. P is equal to 9,000. Find the balance after 3 years, so these will all have t equals 3. For part A, it says compounded quarterly, which means it will be compounded every 3 months or every quarter, which means that that would happen 4 times in a year. So n will be 4. So my formula is A is equal to the principal, 9,000, times 1 plus 0.0146 over n, which is 4, times 4 times 3. I'm sorry, raised to the 4 times 3. Now, just enter that in your calculator. Be careful. Enter this part first, maybe. Hit enter, raise it to the top, 12, hit enter, and then times 9,000. Check it on your own, but you should get $9,402.21. When you're dealing with money, please round to 2 cents, or 2 decimal places, I should say. Alright, B is the exact same thing, except we're compounding monthly. Well, how many months are in a year? There are 12. So the formula becomes 1 plus 0.0146 over 12 raised to the 12 times 3. When you do that, you end up with $9,402.95. So it doesn't change it much. You earn a little bit more. Oh, nope, I was looking at the wrong one actually. It should be 71 cents for this one. So not even enough there. You earn about 50 cents more by compounding it monthly versus quarterly. And that's because the interest rate is pretty low. Now, daily, how many days are there? There are 365. So now we're going to say A equals 9,000 times 1 plus 0.0146 over 365, all raised to the 365 times 3. And when you do that, you get, this is the 9402.95. Okay, so that helped it a little bit more, but again, not much. Now, compounding continuously is the best, but that's usually the most you'll get. So now we're going to use the different formula. It's 9,000 e to the r times t. And when you type that in your calculator, you get 9,402.96, which again is barely more than the compounded daily, because it's happening pretty frequently. Alright, so those are using the banking formulas. Now we're going to do a couple of old formulas. Value of a motorhome, Y, in thousands of dollars again, can be approximated by the model 31 times 092T, where T is the number of years since the car was new. Or I guess the motorhome. Identify the percent annual increase or decrease. Well, our decay factor is 1 minus r, and that's equal to 0.92, which means that r had to be 0.08, which means that it's decreasing by 8%. Estimate when the value of the motorhome will be $9,600. Remember, since we're in thousands, I'm looking at 9.6. So this is where you plug in your calculator. 9.6 equals 31. By the way, it was 31,000 when you bought it, based on this. You guys should know how to do the graphing now at this point. Just plug this into your Y1, plug this into your Y2, find the intersection point, and when you do that, you should see a graph that looks like this. This is 9.6. Graph goes down. And you should find that it's a 14.059 when it's 9.6. So it would be T is approximately 14.059 years after purchase. Okay. So that's just a review one. Again, if you need help with the calculator, I can help you in class. Or watch the video from the day before. I believe I did one of those in the calculator. Alright, this is another radioactive one where I want to know the percent decay, and right now it's written in the half-life form, so we have to split this up using our exponent properties. 1/13 to the t. So you raise 0.5 to the 1/13 in your calculator, and you get 0.94808. Now that's not the percent, that's the growth or decay factor. So we have to say 1 minus r equals 0.94808. So if you get r, if you do the subtraction, you get 0.05192. So it decreases by 5.192% each day. Okay, so that's a review one also. A lot of these are a review actually. This is a review of what we just did at the front page. You invest a certain amount in savings, so an annual rate, so R is equal to 0.025. Compounded monthly, N is equal to 12. After 8 years, so T equals 8, we know that the amount is A. A has 30,000. Okay, so we are looking for P. We don't know what P equals. So let's set up our formula with all the numbers we know. We know what A is. So A is 30,528 equals, we don't know the principal amount, 1 plus the rate over 12, and then to the NT, so times 12, or raised to the 12 times 8. So we're trying to solve for P here, which means we have to divide this whole chunk over here. So when you do that, you end up with, and I'm going to leave it exact right now, P is equal to 30,528 over. Now what you can do in your calculator is just calculate this red box first, and then just do 30,000 divided by the answer. If you leave it exact until the very end, you should get that the initial cost was $24,999.41, so about $25,000, and it probably was $25,000, but if we're going by exact numbers, it would be that. Okay. Now this back page is actually review, and I actually did this in class on Friday, so I actually did it with the day 2 notes, but if you were not here, they are going to be on the video with day 3. So basically what you want to do is set these bases equal if possible. If possible, you don't have to do it with the calculator then. So you should hopefully figure out that this is 2 to the 7th. Since the bases are the same, we can say that x equals 7. Okay, I know that 9 is 3 squared, and I know that, well, I can figure out that 1 over 729 is 3 to the 6th. I need to move that up, so I'm going to make it a negative exponent. Now that the bases are equal, I can say 2x equals negative 6 or x equals negative 3. That will work. Okay. Number 7, I can also use changing the bases. So you should get 5 to the 4x equals 5 to the 12th. And again, you guys should be trying these without help right now, because these should be things you can do. Okay, so that's 3. 8. Here's the problem with 8. 12 breaks down into 2 squared times 3. So we can't get just a 2. So when you have a problem where you cannot get the bases to match, at this moment in time, since you don't know what logs are yet, you have to use your calculator. Okay? So this would be just like those word problems we have where you're looking for the time. So we're going to graph this. 2 to the x looks like that. 12 is up there. And we get 3.585 comma 12. So that means that x is approximately, well, actually I should put in brackets, 3.585. Okay. Good. Number 9 is another one. If you look at it carefully, 15 does not break down to a 5 to the something. It has 2 numbers that it's a part of. So, a 5 and a 3. We have to use our calculator. Again, I already have these done, so you guys can pause the video and try it on your calculator and see if you're getting these numbers, but you should get that it's 1.683. Okay. This one you can use bases because you can get them all to base 3. So I flip this up and I get 3 to the negative 1 to the x equals 1 over 3 cubed. I get 3 to the negative x equals 3, that comes up, negative cubed. So we get negative x equals negative 3, or x equals 3. Okay. Here, since they're both 4s, we can get those down to base 2s. So we have 1 over 2 squared equals, that's 2 to the 6th. Oh, this should still be to the 3x. 6 times 1/3 is 2. So we get 2 to the negative 6x equals 2 squared. So negative 6x equals 2, or x equals negative 1/3. Finally, 12, number 12. The number 18 we cannot break down, so we have to use our calculator. And when you do that, you graph it, and this is a decay, so it looks more like that. 18. So you get negative 2.085 comma 18. So the answer is negative 2.085. Okay. So that is some review, but again, you can't always do it by hand. You have to use your calculator for some of them. Okay? All right, that would be it for today.